Hi everyone, and warm welcome for joining today's webinar, Journey Towards Understanding Model Execution. Without further ado, let's get started and look at the webinar's agenda. Today's webinar will start with the introduction part. Then, later, we will explore what is model execution and what we can achieve with it. After that, we will jump into the tool where we are going to display to you how to build an executable model. Final part of today's webinar will be questions and answers session. Questions can be asked during the whole webinar session by using GoToWebinar application. As I mentioned before, firstly, we will start our webinar with the introduction part. Today's webinar is hosted by me, Gilles Astrale. I'm an internship business consultant at Dassault Systems, where I specialize in model-based system engineering with focus on executable models. I have a master's degree in economics and bachelor degree in electronics engineering. Also, I am OMG certified systems modeling professional. This was a brief info of me. Let's stop our introduction here and proceed further with the webinar's agenda. So what we can achieve with executable models? Let's look into that. Firstly, I'm going to start with a definition of model execution, just to have one common feeling what we can do with it. In computer science, model execution is the process by which computer executes the instructions of a program. In a modeling world, or in CATIA magic world, model is going to be the program which describes the execution sequence. So model is the collection of algorithms, procedures, equations, diagrams, which are used to capture the behavior of the system which you try to model. And in CATIA Magic World, model can be described with UML, SysML, UAF, or any other modeling language. With this in mind, let's continue with the presentation. Another important aspect which I wanted to touch on this presentation, it is the difference between simulation and model execution. Probably you have heard these two terms used interchangeably, but purists would say they are not the same. Simulation is the process of running a model, whereas model execution, it is a process which describes instructions which needs to be executed. So we run model execution to perform system simulation. You might ask, okay, why do I explain these theoretical terms? And this is important if we're looking from the CATIA Magic toolset perspective. We can describe an executable model in a modeling environment. But if we will want to do the simulation, we will need to have an environment which will allow for us to interpret that executable model. We looked what is simulation. Now let's look why we do simulation. Here I listed main reasons why we do simulation. And the first one, that we want to predict the behavior of a real world or a physical system. Also, it is usually cheaper to do simulation than to build a prototype or a real system. And simulation also can be performed at the early stages of a development process. That means we can do simulation way before we have a working prototype. Probably there are more reasons why we do simulation, but I assume that if you're watching this webinar, you already know these benefits. So I will not try to explore that. Just to finish the simulation reasoning, I have found an interesting article which I want to share with you. NASA made a study in which we have investigated how error costs grow in later project lifecycle development phases. And I would say results were quite staggering. They show that both software and system error costs escalate in exponential manner. This is what you can see in my screen. On the left side, you see the study results in the table format. On the right side, you see the study results in a chart format. I believe this is nothing new to you. This is what you have experienced firsthand. The later you find the error, the more cost will be associated with fixing it. From this study, we can conclude the obvious importance of finding errors as early as possible. By leveraging CATIA magic tools, you are able to build an early system models which can be directly executed without the need of generating code, without the need of working with convoluted software. You just build your model specification, you run that model, and you're able to perform simulations. More on this way of working, I'm going to show to you in a demo part. In the meantime, let's continue with the presentation. Now let's look at the CATIA Magic toolset which is required for executing your models. First and foremost, you need to have a modeling environment. So this is a place where you're going to create your system model definition. Model can be created with UML, SysML, UEF, or any different modeling language. But just having a correct model definition is not enough if we want to run executable models. We need to have an environment which will interpret the static model description into dynamic one. And this is a job for the CATIA Magic Model Analyst. So CATIA Magic Model Analyst is a separate software which allows for us to run an executable models. Magic Model Analyst is capable of running execution for UML, SysML, or UEF models. But I need to mention that the best results and the most benefit you're going to gain if you're executing SysML models. In this slide, I'm going to main key features of CATIA Magic Model Analyst. So with CATIA Magic Model Analyst, you are able to debug and animate your models. Also, you're able to create user interfaces. Another feature which CATIA Magic Model Analyst supports, that is automated requirements verification. So you are able to automatically verify your requirement against your model description. Trade studies or trade-off analysis can be performed. Integration with analytical tools is supported. So for example, you have a MATLAB and you want to integrate MATLAB into CATIA Magic Model Analyst. So this is a thing which is possible with this tool. Mass, cost, power, budgets can be calculated. Finally, model-based testing is supported. So you can describe a test case and verify the test case against your model description. And there are more features which CATIA Magic Model Analyst supports. But I think now it's a good time to stop with the presentation part and move to the demonstration part. So just give me a few seconds to prepare a modeling tool and we will start. Okay, I am ready and let's get started. Today I'm using CAMEA Systems Modeler 19.0 Service Pack free version. This is the latest available version. CAMEA Systems Modeler allows for you to model SysML models and also it has inbuilt simulation capabilities. Today I'm going to use the cruise missile project. So in fact, this is the project from the last webinar which was conducted by my colleagues. So they have used MagicGrid method in order to create their project. I'm going to take that project as it is, and I will try to make it an executable project. So the first thing which I need to do, I need to find the block of my system of interest. So in my case, my system of interest, it is the missile. So I am currently in the index diagram, and in this case, the easiest way for me to find that block will be through the diagram. So I will double click onto the missile IBD diagram. I will be in the diagram of IBD. I know that this is the missile from here, and I want to locate the block which contains this IBD. So I will right click on the empty space and go to the context missile diagram. Okay, so I am here. Now the next step which I want to do it, I want to create a behavioral diagram. So if you want to define an executable model, that means you need to create a behavioral diagram. And for today's demonstration, I'm going mostly to use state machine diagrams and activity diagrams. And the first thing which I'm going to do, I'm going to create a state machine diagram for the missile. So right click onto the missile block, select to create a diagram, and select that you want to have SysML state machine diagram. So I have a diagram. This diagram already has a first state, and let's name it. So I'm going to call it off. So the missile always is going to start from the off state. Now from the off, I will proceed where? I will proceed to initialize. Initialize. Okay. So this is the initialize state, and I will proceed into the initialize when turn on signal maybe is going to be received. Okay, so from the initialize, I will go into another state, and this state is going to be what? Let's say ready. So missile is ready to start its mission, and of course, I will go into the ready when initialize is passed, or it is okay. If initialize not passed, so I need to model another state, which I'm going to call it, let's say diagnostics, and here I'm going to say initialize failed. So if initialize failed, the missile go into diagnostics, and from diagnostics it will come back to off. Okay, so from ready, let's model another state. So in this case, I'm going to say fly to target. Okay, and this one is going to be modeled with launch. Of course, we are going to reach this state with a launch trigger. Now let's model another state, and this state I'm going to call it searching for target. So we will reach a designated target area because target area is just not one spot. It is quite a big area where the target could be. So we will need to find the target, and this is what I have just did in my state machine diagram. I introduce the state which will represent the searching for the target, and how I will know that I reached that target. So for this, I'm going to create now a change event trigger. So change event trigger listens for the changes inside the model, and if the condition of the change is satisfied, it is going to trigger that transition. So how to define the change event? Double click or right click and go into specification of the transition. Select here in the trigger field that this is change event, and in the change expression, write your expression. So let's say when the distance to the target is going to be below, let's assume 10. This is an arbitrary number, so let's say 10 kilometers, 10 miles, I don't know which one you prefer. So when it's going to be below 10, that's when uh, it means we have reached target area, and that's when we need to start looking for the target. Of course, this distance needs to be introduced as a variable because now it's currently in the year. So I'm going to create a variable which will represent a distance. So I will select now a missile block, right click on it, and create a value property. I'm going to call it distance, exactly the same as in my expression. And what I will need to do, I need to give it a type. So in this case, let's say that this is real. Of course, as I said, this could be kilometers, this could be miles. I could select from this field, but I just want to make it simple, so that's why I'm going to select it as real. And let's say the default value of a distance, I don't know, let's say 500. So we are 500 miles or 500 kilometers away from the distance, from the target. And when we reach 10 kilometers from the target threshold, that means we will start looking for the target. Okay, I will make now this state a little bit bigger because I already know that it will have not one state, it will have multiple states inside it. So I'm going to create initial, and I'm going to say what? The missile needs to scan for the target and it needs to recognize it. So what it does, it scans for the targets, for target. So it's searching for the target. Maybe there is some visual imaging which is happening and is searching and trying to find the image which matches the image which was pre-uploaded before the mission start. Okay, what is next? When let's say the image is fine. The missile is going to lock onto the target, lock on target, and that's it. Okay, so I need to save the transition here, and let's assume that this one is going to be given, I don't know, it's going to be given by some internal system, so let's call it target located. Okay, let's add now another region, and let's say what is happening here. Let's see what is happening here. So I'm going to create another initial, and once again I'm going to create another state. So while we're searching for the target, we cannot stop just in the middle of the air. We need to fly around the target area. So maybe we are loitering around the target area and we are trying to find the target. So we are loitering around it, and of course our fuel level is not infinite. Uh, when the fuel level drops below some specific value, yeah, that means probably mission is not going to happen. We are not going to be able to reach that target. And what I want to do, I want to model a situation that the missile should destroy itself in the air. So we don't want the missile to drop down onto the ground. Maybe the enemies will take it and do the reverse engineering of it. Maybe it will drop on the civilian places. So this is what we want to avoid. And that's why I'm going to create another state which will say initiate self-destruction. Okay, and once again, I need to specify when it's going to happen. And for this, I'm going to use the same change event trigger. So double click on the transition, go into the trigger, select change event, and select and write the change expression. So I'm going to say fuel level is below, let's say 3%. So once again, some arbitrary number. And when it's going to be below 3%, that's when it means probably mission cannot happen and there is no point of continuing with it, and the missile needs to be destroyed. Okay, and I'm going to create some additional states. So this one will represent destroy target, and I'm going to say this will happen with destroy target signal. And here I will create another state which will say do the self-destruction. So maybe we need to arm, some sort of self-destruction equipment. So that's why I will create another state which will represent self-destruction. So self-destruction. Okay, and after that, the missile will stop existing, and it will reach the final point of its existence. So this bullseye, which is called final state, it shows to us the last state possible for our system of interest. So if our system of interest reaches this point, that means it stops to exist. It stops to exist as it is. So this is what I wanted to say. Okay, so we have now the state machine. Let's try to execute this. Let's try to execute this diagram. And to do that, what you need to do, you need to find the missile block, so the block which contains this sequence diagram. So in my case, this is the missile block. Right click on it, go into simulation and run it. When you will do that, you will see another window which will pop up to you. So this is what we call simulation window. So don't be afraid of it. This is what should happen. Okay, and let's push now the start button. Start button. When you will push the start button, you are going to see that some states or some elements now has a different appearance, different color, or different outline. So this outline, in fact, allows for us to recognize what is happening with a simulation. So if you see the red outline as I have it now on the off state, that means I am currently in the off state. The green one, it indicates the element which we visited at some point in the past. So this one, with this one we started, that's why it is in green. And the yellow one, it shows the element which we visited before coming into the current state. So currently I am in the off and I came into the off through this transition. So that's why this transition is in yellow. Okay, I am ready just to explain additional things which we will need it. So variable window, it shows the variables which are needed for us to perform simulation. Okay, I already see that I made one mistake, but let's try to carry on. So I will select that I want to send the turn on signal, and how to do that, select the state, select turn on. I will go into initialize. If I will send initialize failed, so I will go into diagnostics and automatically back to off. So I need to repeat once again the sequence, so turn on, and this time I will say initialize pass, ready, let's say now launch, and distance, okay, we are going to be in this flight to target state forever until the distance is going to be 10. So of course we don't have time. So what I'm going to do, I'm going to change its value manually. So this is the variable window and this is where the variables are. So if you want to change the value of it, you go here and you select the variable and you write a value to it. So for example, I'm going to say 5. So when I write a 5, what happens? Yeah, uh, I will be in the searching for target state. Okay, and also maybe you have noticed I got an error. So I got an error, and in fact, why I get this error? Why I have this error in my console window? So I have this error because I forgot to add a fuel level variable into my model. So that's why the tool does not recognize, hey, what is this fuel level? I don't understand. And what I should do, what should I do it with it? Why it should be below 3? So this is what it is saying to us, that we have some sort of problem in the model and we need to fix it. So I will terminate it. I will close this window, and this time I'm going to create another value property, which I'm going to call it fuel level. And this time I'm going to say this is, let's say, an integer type. Okay, I did it. And also what I need to do, I need to write a default value to it. So I'm going to say it is equal to 100. By the way, you saw that I typed my type simply with a keyboard. So if you write column and after the column you write a type name, tool automatically recognizes the type and it assigns the type automatically here. Alternatively, as I showed to you previously, you can select the type from this type drop-down list. So this is exactly the same. It is your preference. So I'm okay with that, and I will do exactly the same thing as I did it before. So I will run it. I will clear now my console and see what will happen. Turn on. So I'm in turn on, initialize, ready to launch, fly to target. So I will change it manually, let's say 4, and I will proceed to searching for target. Now I don't see any kind of errors. And if I will be at 3, or in fact 2, so I will go into this state and yeah, let's say I will say self-destruction and I will terminate my execution because when I reach this point, as I said to you, when I reach this bullseye, that means that's it. The execution is stopped, it is terminated, and the system of interest stops to exist. So I will close now this window and yeah, this is the basics of simulation. This is what you can call it. What I am going to show to you now, I'm going to show to you some additional features which you might try to use it if you want to, let's say, utilize simulation in more complicated way or more su sufficient way to you. So everything what I did it here, everything I did as you saw manually. So I selected signals. If I wanted to trigger them, I wrote the values manually. If I want to trigger some transition, everything was done automatically. Let's try to make, sorry, everything was done manually. Now let's try to make it more automatic, and let's try to create this model description here. Okay, so the first thing we have a distance. Okay, the first thing we have a distance, and we want to say, okay, when the distance is going to be below 10, that's when we should trigger the transition. As you saw, I did this triggering manually. Now I'm going to make it automatically. Okay, so now in the missile block, I will create an activity diagram, and I'm going to call it distance. Okay, here I will create initial node. And this initial node, what it will do, it will show to us the starting point. The next thing which I'm going to create an opaque action. So opaque action will allow for us to manipulate our variable. So I'm going to connect these two, and I'm going to say distance. So I will copy distance is equal distance, let's say -1, or maybe let's increase it. -5, let's say. Just make the step a little bit bigger. Okay, and let's assume that from the previous project, from the previous knowledge, we know that we fly at least 5 kilometers. So 5, let's say it represents miles, kilometers, I don't know, which you prefer. So we know from the previous experience that 5, this is the distance which can be covered by the cruise missile every 1 second. So I want to introduce what? I want to introduce now a time event. So I will introduce a time event, and I'm going to say, okay, every 1 second you should decrease the value of this. So you should decrease every 1 second the distance value. And of course, if I will leave it as it is, it will just be for one time. But as I said, I want to make it until forever, yeah? So that's why what I'm going to do, I'm going to create a merge node here, and I'm going to connect this guy to the merge node. This is what I did. Okay, very simple diagram. Now, when I will come back to my state machine diagram, I will select this distance activity, and I will drop onto the fly to target state. I will assign it as a do. Okay, so what will happen when we will reach fly to target state? We are going to decrease the distance every 5 kilometers. And when we are going to reach below 10, the value below 10, that's when we are going to trigger the transition, and it should happen automatically. Okay, that's the first thing. Also the same thing what we need to do, we need to do the same thing for the fuel level. So let's try to do also pretty much exactly the same activity. So I will select missile. I will select that I want to create a diagram, and I will select once again an activity. So I'm going to call it fuel level. Here I will create initial node. I will create once again opaque action, and here I'm going to say fuel level is equal fuel level -1. Okay, we are set. Once again, we need to create a time event. This time I'm going to create time event with 1 second. I think this is what I did also previously. And also I need to have a merge node. So I will create a merge node which I will connect to here. I will do exactly the same thing here. I will come back to the state machine. I will drop this fuel level onto the loitering. It makes sense because when we are loitering, that's when the fuel level drops. And I will continue. Okay, so if I will now try to run the execution, let's see what will happen. So simulation, select the missile block, go into simulation, run it, and let's see what will happen. So start, off, turn on, that's good. Send, let's say turn on. This is the signal from the user. So of course, it doesn't make sense, to model it automatically. I will leave it. Initialize, pass, fail. Probably this is what it is done by missile itself, but in this case, I will still select it manually. So pass, ready. Now the launch, once again, this is probably what it is done by the missile operator, not by missile itself. So I will select launch. And now what is happening? The the activity diagram was triggered and it is changing the distance value every 1 second. It is in fact reducing it by 5. This is what you see here. It is reducing its value by 5 until we reach that 10. Until we reach that 10. Probably, yeah, we don't have time for waiting until it reaches this 10. So I will pause the simulation and I will make this value to, let's say, I will make this value to, I don't know, let's say 5. Not 5, let's say 17. Okay, and I will resume the simulation. So it dropped to 12, it dropped to 7, and we reached the 7. So the 7, it is below 10. So we are in the searching for target state. And now the fuel level is dropping. Probably I should add this fuel level once again. I should add this fuel level into this state, not as a separate activity. So what I could do, in fact, I could write here in the expression. This is also a tip to you. So what you could do, you could give a semicolon and you could say fuel level is equal fuel level minus 1. So in this case, the fuel level would drop by 1%. And in fact, this would be applicable to the whole diagram when the missile is flying, not only to the searching for target area. But in this case, let's follow that and see what will happen. Once again, we don't have time to waiting until it reaches 2 or less. So what I'm going to do, I'm going to say this is 4. I'm going to give a value 4. So now it is 3. Now it is 2, and we initiate the self-destruction. But what is the limitation here with this kind of diagram? That we still don't proceed to the self-destruction or to the destroy the target. So we need to add additional elements here, and let's do that. So once again, I'm going to approach this problem with the same activity diagram. I'm going to create an activity diagram, and in this case, I'm going to say start self-destruction. Start self-destruction, and this will be once again very simple diagram. It will have initial node, and if I will come back to my state, it should send this signal, self-destruction. So I need to find my self-destruction signal. In my case, it is here in the missile state machine element. So self-destruction, it is here. I'm just going to select it, drag and drop it, and I will have it. I will connect these two. If I want to be precise, I will also create an activity final, but if you don't do that, this will work also. So I will come back now to state, and I'm going to assign the start self-destruction here, maybe on entry. In this case, it will not make any big difference if I will assign on entry or on do. And I'm going to do exactly the same thing onto the lock target. So once again, the procedure is exactly the same. I create an activity diagram. I am going to call it target found. And I'm going to create, in this case, what is the signal? How it's called? Destroy signal. Okay, destroy. And once again, I'm going to create initial node and activity final. I will come back now to the state and once again repeat the same procedure. So select an activity, drag and drop onto the lock, onto the target. Once again, in this case, I'm going to select do. As I said, it will not make any difference if this one is entry or if this one is undo. So what will be the execution now? Let's see it. Okay, we are in off. I will select turn on, initialize, pass. Let's say launch. We reduce the distance. Yeah, you also see now we also reduce the fuel level because I said it. I said it in my activity diagram. So I'm going to reduce this value, let's say to, as I said previously, let's say 13. And this one I'm going to give it, I don't know, let's say 5. I will change it and I will continue. So now it dropped to below 10. So we are in these two states. Fuel level is dropping. We reach 2. We initiate self-destruction. We send self-destruction signal. We go into the state and we proceed into the final state, that is termination of system of interest. Okay, so this is the behavior, let's say the behavior description, at least in a nutshell. Yeah, very quickly without more details. Of course, you could do much more complication, but as we are limited with the time, I'm not going to do that. One thing which I wanted to explain to you now, it is the user interface. So everything what I showed to you here, everything I did it, let's say by selecting elements in the containment tree, by using simulation window. On one hand, this is quite a good approach, but probably what you would want to do it, maybe you don't want to look into this variable field. Maybe you want to do it uh, in some different way. So what I'm going to do, as I said, I'm going to create now an user interface. So in my model tree, I'm going to create a package, which I'm going to call it, let's say, UI. Okay. And here I will create another package, which I'm going to call it GUI. Yeah. And I will create inside this package user interface. Okay. You are not going to see anything if you're not going to be an expert. So go into the expert. And when you are going to be an expert, you're going to see interface modeling diagram. So select to create this diagram. Now I will try to model. I will try to model this kind of GUI. So I will create a frame. So my frame will represent a missile. So that's why I'm going to select the missile block and drag and drop it onto this frame. What else? So you saw I used the signals: turn on, initialize pass, launch. What else? Target. Okay, this one I didn't use it, but I used these signals. So I wanted to be displayed on my frame. And the process here is pretty simple, in fact, as I would say. So you would go where? You would go into the state of the missile. And for example, I want to see turn on, so I select turn on signal. Okay, what else? Initialize past. As I said, probably initializing status. This is probably what should be decided by the missile itself. But in this case, let's assume that the operator decides if the missile is ready for the launch, if it's not ready for the launch. So initialize failed. Okay, and the last thing, launch. Yeah, this is the last thing. That is launch. Okay, so these are the signals. What else? What else? Remember, I had two variables. That is one for the distance and another one for the fuel level. Okay, that is fine. So that is fine. And I want to display them on my GUI. So how I do that? Now I will go into the text, and firstly I will select, I don't know, maybe label. So label will represent a specific variable from my model. So let's say in my case, it will represent the fuel level. And label is not editable, by the way. You're going to see that. Or another option it is to have a text field. So text field, let's say this will be for the distance. Oh, you know what? Maybe I'm going to use also text field here. Okay, so I'm ready. Just one thing, this should be fuel level. I'm ready with my GUI, very simple, very easy to make it GUI. So I will finish here. Just one additional thing which I need to do, I will create a simulation diagram. So simconfig, I'm going to call this package. And this package will contain simulation diagram. So simulation diagram, this is the diagram which allows for you to configure your simulation execution. You could do many things with it, but as this is, let's say, a webinar for the users who are just starting to work with the simulation, so I will not go into these complicated things. I'm just going to give this simulation config a name. So let's call it simconfig and one. And I'm going to say what? I'm going to say that, where is my model? Where is my, sorry, this is where my missile is. I'm going to say this one is representing the missile. And also the GUI which I have created should be displayed with this simconfig. So I will select GUI and I will drag and drop it on the simulation config. So now I don't need to locate that missile block from my containment tree. What I just can do it, I just push this button here, run simconfig, and I will have the simulation, and I will have GUI for my simulation. So in fact, if I will come back into my state machine, I can push the button here, turn on, initialize path, launch, and when I launch, the distance should be reduced. Also, this one should be reduced. That is the fuel level. So I will pause it. So I can change it, for example, to, in fact, I didn't pause it. Now I will pause it and I will change it, for example, let's say 5 as previously. And in this case, I will change it to 13. Okay. I will resume my simulation. So now it dropped. I proceeded here. When the fuel level drops, I will go in this way. So this was a GUI creation. This is how you can do it. As you can see, your GUI can be made very simple in a simple way, and it also can simplify your understanding of simulation. Okay, and as I see, I have few minutes remaining, and in these few minutes, what I wanted to demonstrate to you, I wanted to demonstrate the usage of parametrics and requirements verification. So I have requirements. In fact, these requirements were imported in the last webinar from the Excel. Let's say in my case, I'm going to use doors. So I want to import requirements from the doors. So I will use Data Hub. So this is a tool which allows for you to import the requirements, let's say from the IBM Doors tool or maybe from some other different tool. So when you start the Data Hub, this is the Data Hub Explorer window, which is available. So what I need to do, I need to select what kind of connection I want to have. So I will select IBM Rational Doors. I will push the Create button. Okay. And now I'm going to see the database of my door. So in fact, this is the database here. So I have some requirements. And in fact, there is one requirement which is missing compared to what I see it here. I want to have it inside my model. So I'm going to select this requirement and I'm going I'm going to manually import it inside my model. So I'm going to place it inside here. Okay, the tool is asking, do I want to do a synchronization? I agree with that. Okay, the synchronization of the requirements was done. And if I will update my table, okay, this one does not work because there is no scope. So I will define the scope. And when I will define the scope, I see the requirement which I took from the doors. And this requirement is stating that the flying distance of a missile shall be at least 220 kilometers. And I want to calculate that. Okay, so let's try to do it. In the containment tree, let's go to find our system of interest, that is missile block, and create parametric diagram for it. Okay, clear everything we don't want to see. And here, select to create a constraint property. So I'm going to call this fly distance. Okay, I have it. And the formula will be very easy. So fly distance is equal fuel mass divided by fuel consumption. Let's parse out the parameters and display them. Okay, so we have three parameters. We need to connect them to the value properties, but we don't have value properties. So let's create value properties which will be connected to these parameters. So I select missile block, create element, create value property, and I'm going to type it first one, which will be total fly distance. This will be, let's say, real, and because it will be calculated, I'm not giving any default value. I will connect it to here. Fuel mass we don't know. I'm going to approach it a little bit differently. And fuel consumption, let's say we know it. So once again, I'm going to create a value property, which I'm going to call it fuel consumption. Then once again, this will be real. And let's say we know from our, let's say, previous results that the fuel consumption, it is 0.5 kilograms of fuel every 1 kilometer. So I'm going to type this kind of thing here. And I'm going to display it also in the diagram. Okay, I have it. Now what we should do with the fuel mass? Of course, we should calculate it, but in my case, I have a MATLAB function which in fact calculates the fuel mass. So I have MATLAB file which does all that calculation, and I want to connect that MATLAB with this SysML model. So I will show to you now a MATLAB file, and this is the function which calculates the fuel mass. So basically the idea is what? We have a fuel tank, which is a cylinder type. We calculate the volume uh, for the fuel tank, and when we multiply that volume against the density of the fuel. Simple formula. And I want to have it inside my SysML model. The process of that is easy. I need to locate that MATLAB file. In my case, I already did it. So it is here. And just I will drag and drop that M file into parametric diagram. The tool will automatically parse out that MATLAB file. And we need to connect now the remaining parameters. So fuel mass should be connected to the fuel mass. That's fine. But we don't have these three ones. So let's create a value properties which will represent fuel density, tank height, and diameter. So fuel density, probably this is a parameter of a propulsion system. So I'm going to create a value property for the propulsion, and I'm going to say fuel density. Okay, I will give it a type. So I'm going to say maybe this is integer. Usually densities are integers. And the default value, let's say it is 770. So this is the standard value for the avionics fuel. So 770 kilograms per cubic meter. So this is the fuel density. What else? Diameter. So this is probably the parameter of structure. So I'm going to call it diameter, or maybe fuel tank diameter. This one will be real. And in fact, I don't know it. I am going to give it a default value, but I need to optimize. I need to optimize it to meet my requirements. So just for the start, I'm going to give it 0.4 because I need my formula to be calculated. If it's going to be equal 0, of course, everything is going to be equal to 0. So that's why I'm going to give it this kind of value. And the tank height, this is exactly the same. I need to create a value property, which I'm going to call it fuel tank height. Okay, once again, this will be real. And let's give it once again, some sort of arbitrary number because we need it for the calculation. I'm going to give it 1. So let's say this is 1 meter of height. And yeah, now I'm ready. Just one thing which I need to do, I need to place these value properties inside the diagram, but I'm not able to do it. I'm not able to do it because these values are not in the missile. But what I can do, I can go into display and I can select display parameter properties, clear all. And here I'm going to select these value properties. Okay, I have it. Now, just this is the matter of connecting them. So tank height here, tank diameter here, and fuel density, it is here. Okay, let's do quick layout and we are ready. So now if I am going to run execution for this simulation config, we should get a total flying distance, and it was calculated. Currently, it is equal 193. Yeah, we probably remember that the requirement is not met, so we can maybe probably increase this thing, so diameter, and we see, yeah, now we meet the requirement. But we need to remember that requirement every time. So maybe, when I have a good day, I will remember that. But when I have a bad day, probably I will forget it. So what we can do, we can make this requirement to be verified automatically. So how we do that? I'm going to go into the missile logical architecture diagram. I'm going to layout it and I'm going to display that requirement. So this is the requirement which I have it. Okay, I have it. The next step, it is to connect my value property, total flying distance, to this requirement. And I'm going to connect that with satisfy relationship. I did that, everything is fine. But if I will run execution, nothing will display this information to me. Okay, let's ignore that. Let's ignore that. I will terminate that. Nothing happens because one setting by default, it is set to false. I need to enable that setting to true. And where I go into options, project, general, once again, general. And here you see this property, use requirement terms glossary, make it a true. Push OK, and when you will do that, you see the underlines underneath the requirement text. So the tool is automatically parsing out the text, and it is giving some sort of uh, constraints to them. So for example, if I will hover my mouse key, it is saying that the total flying distance should be more than 220. Let's try it now. So I will run the sim config. And you see now the requirement is displayed in the red. So it means the requirement was not satisfied. If I will change its, for example, fuel tank diameter to 0.45, yeah, I think this was the value. And I will push enter, now the requirement becomes green. So it means the requirements now is satisfied with this set of parameters. Of course, we can save these parameters into the model, but I guess this is the time. This will be displayed maybe in another webinar. And currently, as I see, we are running out of time. So I will stop here and I will go into the questions and answers session.